Hi guys, we're going to have a look at Simplex tableau today, which in my opinion is the most challenging topic in the decision book. Not because it's particularly difficult to understand or it's a complex method, it's just so easy to make a numerical mistake and carry that mistake through. So what I thought we'd have a look at first is the example from last lesson, which was the woman who made loads of cakes. If you remember, we looked at changing these inequalities into equations by introducing something called slack variables. So variables which are just there to take up the slack. We can solve this graphically, like some of the previous questions, because we have X, Y, and Z. We also now have R, S, and T. I can't just plot it on a piece of graph paper and work out a feasible region and then do the objective line method or the vertex testing method. I've got to take a different approach. And that approach is the Simplex algorithm. It's a technique which, in my mind, is a little bit like solving simultaneous equations and a little bit like vertex testing. So if you imagine trying to solve these using simultaneous equations, you might say, let's take this one away from this one, and that would eliminate the y here. You could maybe take two of these away from this, and that would get rid of the x. So there's a little bit of that involved with all the manipulation of equations that we're going to be doing. If you think about it as a 2D graph and doing the vertex testing, you can also consider looking at each vertex in turn and seeing if it's the right one. You won't notice it happening so much in the table, but there's a little bit of that involved as well. So I'm going to show you how to put this one into a tableau. I'm not then going to solve this because these numbers are so big, they're a little bit challenging for me to deal with on this kind of format. So I'm missing first an S, that's meant to say such that. I've got my three constraints here, and I've got an objective function. Now my objective function is in a different format to the constraints. So I'm just going to change that first and bring it all over onto one side so that it's equal to 0. I can now put these into a tableau. Right, I've copied them across again. It's a very big tableau because I've got a lot of variables. I've got X, Y, Z, R, S, T. Now, basic variables, they start off as your slacks. So I'm going to put R, S, and T in here. They start off as my slack variables because the most basic solution for this problem would be if X, Y, and Z were 0. And if X, Y, and Z were 0, then R would have to be 3000, S would be 2000, and T would be 1500. So a very basic solution is that X, Y, and Z are 0. And so we start off by putting these in our basic variable column, and these are going to be the ones that we initially give a value to. Along here, I'm going to substitute in my equations. So, equation 1, I have 220x, 100y, 250z, 1r, no s's, no t's, and that's 3000. Second one, I've got 100x, 100y, 50z, no r's, 1s, no z's, and that's 2000. Final one, 50x, 100y, 75z, no r's, no s's, 1t, and that's equal to 1500. Now for the objective row, I'm going to do it in a different colour just so you kind of think in your head that it's slightly different. I'm not going to treat it in exactly the same way that I would the constraints. So I'm going to put minus 10 in here, minus 18, minus 12. There's no slack variables for the profit equation and it's equal to 0. So although we're going to do row operations on the whole thing, including the objective row, I'm not actually going to be using this as a pivot at all. So that's just me entering this into a table. I'm not going to try and solve it because these numbers are just too big for me to deal with. I'm going to work through a much simpler one with you. But the idea here, our S&T starts off as 3,000, 2,000, 1,500. Throughout the process, you would then start considering maybe X instead of R. You might consider Y instead of T, for example. And those are looking at different vertices and seeing which of those is the optimum one. You'll notice there's negatives down here. That means there's improvement to be made. So if any of these values down here that I keep erasing by accident are negative, then that means there's an improvement to be made to the profit. As soon as you've got only positives down here, there's no improvement to be made. Have a quick read through the Simplex method. However, I find it's very challenging to understand until we've actually worked through an example. Okay, so I'm not actually going to pause for very long in real life. I'm sure you can pause the video, but I might keep going back to that and referring to it. But like I said, going through it as an example is so much easier. I have got a much nicer example here. I've got a lovely objective row and I'm using P for profit. I don't think I mentioned that earlier. I changed the M to a P. I think it was back here. Yeah, here I changed M to P. That's because that tends to be the letter they use in the exam and in the textbook. So I just changed it to P for profit. I've only got two equations, which is lovely, two slack variables. It's going to be a lot easier to deal with. So, first thing to do, I've rewritten my objective function. My most basic variables, again, are the slack variables. And I can now leave a gap here between my constraints and my objective row, which is nice to do if you can. It just gives you a bit of, just a little bit of kind of separation between them. So I'm going to fill these in. So first one, 1x, 3y, 5z, 1r, no s's equal to 45. 1x, 2y, 4z, no r, 1s equals to 25. And my profit function, minus 3, minus 4, minus 1, 0, 0, 0. So our first solution is that R is 45, S is 25, X, Y, Z are 0. And that is a solution, it's just not a very good one. Now the first step in the Simplex method, it says if they're all non-negative, then we found an optimal solution. Otherwise, choose the most negative entry, and that's your basic, introduce that as a basic variable. Okay, so what we need to do is look down our objective row, so look across our objective row and see which is the most negative, and it's this one here, -4. That's where the most improvement can be made. So that is going to be my pivot column. I now need to decide what am I going to use as my row, and this is not an option here. And the Simplex algorithm tells us to look for the non-negative, the smallest non-negative value of theta. So to work out theta, theta is the value divided by the coefficient of y in your column. So I've got theta equals 45 divided by 3. I've got 25 divided by 2, and you choose the smallest. It's got to be non-negative, but they're both non-negative. So we go for the smallest. That means I now have my pivot row. And that is actually called a pivot element. So what we're going to do now, we would swap S with Y because we're considering Y instead. We're saying we can make the most improvement to Y. So I'm going to investigate a vertex with Y instead. So that will swap with that. I'm going to try and change that to a 1 and eliminate Y in the other equations, like you would with simultaneous equations. So that's going to become 1. These are going to become 0. So we eliminate Y in every equation other than the one we're actually dealing with, our pivot row. So I need to take that entire row and divide it by 2. So I've just copied across my tableau there, okay? And I've circled the pivot element. I'm now going to take that row and divide it all by 2. So at the same time, I'm going to replace my S with Y. So notice that change of basic variable there. So divide 1 by 2, 2 by 2, 4 by 2, 0 by 2, 1 by 2, and 25 by 2. So that is my new row. So that's my row 2 divided by 2. Okay? I'm now going to use this row, and I sometimes highlight this. You can't do it in the exam, but for practice you might want to highlight it. This is the row that I'm going to use in order to send these other elements to 0. So I want to 0 here and here. And I'm going to do combinations of this row to get it. I'm going to put R in there because that one hasn't changed. So I've got 1 here, 3, 5, 1, 0, 45. This is the one I want to change to 0. Remember, so I'm going to take this element. To make it go to 0, I'm going to have to take away 3 lots of that one. So I'm going to have row 1 and I'm going to take away 3 lots of my new row 2. So 3 take away 3 lots of 1, that goes to 0 as I want. 1, take away 3 lots of a half, not such an easy number here, and this is where a calculator is really important. I haven't got one with me, so please wish me luck. 5, take away 3 lots of 2, -1. 1, take away 3 lots of 0, hurrah, that's a nice easy one, lovely. Then I've got 0, take away 3 lots of a half, that will be -1.5. And then I've got 45, sorry, let me just undo that, 45, take away 3 lots of 12.5, that gives me 7.5. Now I'm going to look at this row. I want this element to go to 0. So I'm going to look at what I can do to -4 to make it go to 0 here using only combinations of that row. So it's going to be -4 plus 4 lots of that one there. So my row 3, I'm going to add 4 lots of row 2. -3 plus 4 lots of a half gives me -1. -4 plus 4 lots of 1 goes to 0 as wanted. -1 plus 4 lots of 2, 7. 0 plus 4 lots of 0, oh thank goodness, nice easy one. 0 plus 4 lots of a half, 2. and I've got 0 plus 4 lots of 12.5. So I've got 50 there. So this is my first iteration done, and in the exam they will quite often just get you to do one iteration. Now I have got a solution here. I can read it off. R equals 7.5, Y equals 12.5, and all the other values would actually be 0. So R equals 7.5, Y equals 12.5, X and Z would be 0, and so would S. It's obviously not optimum because we still got this negative value in here. We can give that a little bit more of a push to increase the profit. So we haven't finished here. We found a solution, but it isn't optimum. So I need a second iteration. I've got exactly the same values there, okay? I hope I do anyway. And what I'm going to do is repeat the whole process again. So I look at my objective function. I choose the most negative element. It's the only negative element, -1. I work out my theta values. Now, in the first one, it's not applicable because if I divide 7.5 by a negative, I get a negative. So I haven't actually got a choice here. 12.5 divided by a half, I'm kind of stuck taking this one anyway. Okay, so this is going to be my pivot row. That's my pivot element. Now, it's perfectly fine that we're replacing the variable we've just replaced anyway, not a problem. You might find that happens fairly often, and especially as we've only got 2 equations, it was probably going to happen. So that is now my pivot element. I want that to go to 1. So what I need to do is I'm going to put an R in there first, and this time my Y is being replaced with X. I want all of this to be times by 2 to make that a 1. So I'm going to take row 2 and I'm going to, I'm going to take row 2 and I'm going to times it all by 2. So I get 1, 2, 4, 0, 1, 25. I'm now going to use this row to make these go to 0. Okay, so I want to eliminate X here and here, and I'm going to use row 2 to do it. So I've got -1/2 here. To make that go to 0 here, I'm going to have to add on 1/2 of 1. So row 1 plus 1/2 of row 2. I'm going to fill in the numbers, and then if you take just a moment, maybe you can pause it and see if it is definitely correct. This one here, I want to go from -1 to 0. So all I have to do here is add on row 2 to row 3. So that one's quite a nice one. So row 3 plus row 2, I get 0, 2, 11, 0, 3, 75. Notice we have no negative values down here. We have got an optimal solution here. So I've done a second iteration. We've got an optimum solution. So no negative values. So that means we found an optimal solution. This is brilliant, no more iterations here. I have done questions where I've had to do 7 or 8 iterations, and it's made me want to cry. Now to read off the solution from here. So we've looked at a couple of different vertices. We started off with R and S being 0. We then brought Y into the solution. It wasn't quite good enough. We've now brought X into it, and it seems we've got our optimum solution. So, to read off here, R is equal to 20, X is equal to 25, P is equal to 75. So R equals 20, X equals 25, the profit is 75. It means that any values which are not in the basic variable column are 0. So I know it seems a bit weird here. We have got a value for our slack, But whatever we're making or producing here, we should only really be producing X. That gives us the best profit. Y and Z shouldn't be dealing with that at all. And what I can do here is also just prove to you, other than saying here, well, there's no negative values here, so it must be the optimum solution. What you can do, if I write down the profit equation, I've got P plus 2Y plus 11Z plus 3S is equal to 75. If I just write that in a slightly different way, I'm a little pushed for space here. Let me just do that. If I rewrite that as P equals 75 minus 2y minus 11z minus 3s, it's a little bit clearer here to show that if you increase y, z or s any at all, what that does is cause the profit to decrease. So if the question in the exam was, how do you know you've got an optimal solution? You can say there's no negative values in the tableau, but also if you have your profit equation written like that, you can say any increase now in y, z or s would cause a decrease in the profit. I know that is a very challenging algorithm, but once you've done it a couple of times, it's not actually too bad. And the difficult bit is making sure you don't make any numerical mistakes. Now, I will admit, I've made this video 3 times because I kept making numerical mistakes, okay? I'm human and I haven't got my calculator with me. I've got a couple of questions for you. I apologise that there's no templates to print, and all of these will need you to draw tableaus. What I strongly suggest you do is make one like this, but you might want to include another column there in case you've got a slack variable t, and maybe add another 2 or 3 down here. And then if you're able to, print some off so you're not drawing them again and again, because some of these questions might require you to do 3 or 4 tableau. Have a go at them. Please email me or message me on Show My Homework if you've got any questions. Send me the work, let me check for errors if you want, whatever you need. Okay? After that, it does get quite complicated. It gets a little bit harder, but again, it is still just the problem of making numerical mistakes. Okay? Best of luck. Take care. Bye.